Hello, everyone. Thank you for taking the time to listen and watch this webinar with the title Consistency of DFMEA, PFMEA Control Plan, PFC and Special Characteristics. My name is Andreas Wilhelm. I'm consultant at Plato, and I would like to show you a live presentation in our Plato 1 tool with hopefully all these topics which are there in the headline. So what is this webinar about? It is quite simple. It is about pizza. So last time I made such a presentation, I started with a pizza example, and I made this example from the beginning, design FMEA, process FMEA, and so on, about a standard pizza. And today I want to modify this pizza to a gluten-free one. So in modern times, we have new requirements. Also, you in your industries, in your products have new requirements to fulfill. And I want to show you how this new requirement will, can be handled in our tool in Plato 1 through all those methods. Of course, this webinar is about DFMEA and PFMEA and how they live together in peaceful harmony. And of course, there are some other methods around, like requirements, special characteristics, control plan, and process flow chart. And in detail, and there is a big cycle around. And in detail, we have, of course, all those methods which can be used in our tool. And this is what I want to show. So that was all about the presentation. Right now, I want to step over into the tool, into my Plato 1, and which is already there. And first of all, I want to give you a quick overview to this pizza example. So I'd like to step into, first of all, I zoom in a bit for you. Maybe 110 is good. I'd like to step into the design FMEA. And of course, it's already open because I prepared this example. Let me hide the other project. So this is the design FMEA of this pizza. I made a copy and I called this copy already gluten-free pizza napolitana. So the content you see is the original pizza example, and we are going to build a gluten-free pizza now of this. So what do we see here? We see the design FMEA, a little bit of it, of course. I did not finish it completely, but you see here a function, higher level function, lower level function. You see failure, so pizza base is not crispy enough, with effects on the higher level and causes coming from the lower level. And if we like to see how it is linked together, we can have a quick look into our net builder to see now how the failure nets were built. So you see here again this failure, pizza base not crispy enough, with all the causes, and you can see there are causes coming from let me say the single components, like here in this case the duff, but also further down here causes coming from the process. So this icon here indicates a process element, so the pizza making process, and of course also here here is a link between design and process, coming or created usually from the process FMEA side, searching for the effects of a process failure in the design FMEA. So this link is also visible here. So this FMEA is linked through, and you can see these process failures have further causes on a lower level. You'll see later. So this is the design FMEA, and just to focus on one thing, which will be our topic today, the flour type. When I go here to my duff, for example, I can directly jump into that level. That's one level below. You see here now my flour. I would call this a characteristic level, and the flour is specified here, like others, like the yeast, like the salt, and so on. So there are some specifications defined, and also already some some special characteristics here. In case of the water amount, there is already an SC, special characteristic, functional defined. We'll see that also later. Having a look at the process FMEA now, I make a quick jump into the process. You can see now, yeah, the other side. Let me say it this way. Here I have the DAF making process, also with higher level functions, lower level functions, and you see here this failure DAF consistency incorrect, which has an effect. Pizza base is not crispy enough, and you see the effect at a severity rating forwarded through the failure network down to DAF consistency incorrect, and it has its causes itself and the risk evaluation here as well, with some imagined recommended actions and so on and so on. And at the end product, what we need is, of course, a control plan, and this is also already existing here. You see, I only have the process step DAF making here in my control plan for the moment, and you see here the product characteristics. Here is this water amount I showed you. I have some other characteristics as well, and also a process characteristic in here. And I filled in with some further ideas of measurement technique, size, and so on. So all data is linked together from one data model. And of course, this pizza example should be modified now. It should become a gluten-free one. And this requirement to make a gluten-free pizza comes typically from the management, and is typically entered in the top level. We have this top level element here, gluten-free pizza experience. So that's the higher level element I can show you. And I go to my requirements method, and I'll find here an already existing definition of my unforgettable pizza moment requirement. So that was the initial requirement for the first project. Here you have a description for a perfect world best pizza, and I'd like to add now a new requirement in here. Just Control Enter, and then I can say, okay, ensure gluten-free consume. You see a new line is entered here, and I can now further describe this new requirement. So with many words, or I will keep it simple and say, 1 second, let me scroll down here, max ppm equal to 20. So 20 ppm gluten are allowed to be in my pizza. I don't know for sure, but I found some definitions like that for gluten-free. So that is my requirement now. All right. So that's it for here. I want to go on now and bring this new requirement into my structure, into my pizza project. And our tool for that is our architect. And architect is the module for building system, function, and failure networks. Seems to be the best tool to do that. And well, you can see I had it opened before. I need to update here after having entered something in another module. And you see now, get an unforgettable pizza moment as the first requirement here, and ensure gluten-free. I have to edit this one. Oh, why not? 1 second, now it works. Okay, just my mouse did not react. So ensure gluten-free consume. And when I select the unforgettable pizza moment, I can see that there are also already sub-functions linked, and these sub-functions can be found here in my pizza. So this is the function, the first step of the function analysis. The pizza is already there, so the structure is built, but which are the functions to to provide an unforgettable, or to support this requirement to get an unforgettable pizza moment. So here are the functions: the world best crispiness, and so on and so on. And none of the functions fit to our gluten-free consume. That's why I would add a new one. And again, just Control Enter. And the function I want to add here is ensure that pizza is free from gluten with an N. So a new function is added to my system pizza now, and I can link that function by ticking that checkbox here, and you see a function network is being created. So this is now how I can translate such a requirement, a high-level requirement, downwards in such a system structure to my subsystem elements. This function network down here, or this network, is a nice visualization, but also an instrument for navigation. So instead of selecting the next system element or something like that, I can just focus on another element in that network just by double-clicking, and you'll see that the tool switches downwards to the pizza. So that is now my product level, and well, you can see that the functions of the pizza are now here in the horizontal direction. And well, of course, sorry. And next thing you can see is my subcomponents, my subsystem elements. In my pizza example, it's the duff, pizza base, pizza sauce, pizza topping, and the pizza making process, which is not part of the BOM, but they are member of the BOM. So the process is, of course, not a design element, but important here, and it also takes part on the functions of the pizza. So the first step now is to discuss and to decide which of my subcomponents play a role in that new function, ensure that pizza is free from gluten. And of course, the team decides, well, it is the duff. So the duff, that's clear. Pizza base, pizza sauce, pizza topping, they do not play a role here, but the pizza making process, right? And if I expand now the duff, I can go on and make it a bit more detailed because I have now my characteristics level here. So this is not a functional description, this is more a characteristic description. I have the flour, yeast, and so on, and here it is only the flour playing a role. So the flour is responsible to ensure that the pizza is free from gluten, and this makes sure that our customer ensures gluten-free consumption. Now let me build the bridge to the process FMEA. It is also there, and it is also there with its functions. So I have a simple process FMEA here with duff making, duff rising, and so on. And of course, the duff making process plays a role here and has to make sure that my pizza is free from gluten. But also forming the pizza base could be a critical situation when you mix up, for example, duffs with and without gluten. And we said, or I said, also the pizza baking, because the oven has to be cleaned or whatever. So I'm already thinking in failures. Now I'm thinking only in functions. So, well, that's my function analysis. And just to visualize, you can see here this function network for my pizza. So let me go back to the top level and let me enter step 3. Step 2 in my 7-step approach is the function analysis. I'd like to enter now step 3 of my 7-step approach, and this is the failure analysis. And the tool has already switched to the failure key aspect, and you can already see failures here on the top level. And well, I would like to add a new failure on the top level, and this can be easily done also here in Architect, just by right-clicking on a function and say new failure, and my new failure on this top level should be an allergic shock. I want to have it a bit more dramatical, so this is on this top level. This will become, or will be, my, let me say, yeah, my failure effect at the end of the day. And I can go downwards to my pizza level. I have this function here, this to ensure that pizza is free from gluten. And I can also easily add a failure here, which is called pizza contains gluten. Of course, I can add several failures, but in this example, it is quite simple. And by ticking this checkbox again here, I can see a failure cause combination, or I can see the cause effect combination depending on which level you put the focus on. Of course, the level of the pizza, this is my focus level. So I will go there, and you'll see the failures up here in the horizontal line, at functions and failures here in the horizontal line, and you can see the failure network down here. But I'd like to show you another little tool here within the ANS Architect. This is our net builder. So let's go there. It can be entered here with this button at the bottom left corner of this graphic window. And the net builder shows you, yeah, let me say, in the main window here, the same view than before. It's the failure network, or if you like, the function network. But it also shows you the higher level functions and failures and the lower level functions and failures. And in the net builder, you can also build these networks. So this link can be also done here to the higher level as well as to the lower level. And well, you can also edit data in here. You can enter new functions, you can enter new failures, you can even enter new system elements. So everything is possible here in the net builder. So let me show you what I like to do, or how, yeah, I want to work into the course direction. I want to ask for the courses now. Imagine with an FMEA team, and I ask what could be a course for pizza containing gluten. Well, you see the flour, the function, or this characteristic flour is marked because it is part of that function network. You can see here, so it is marked when I select the failure, and of course this indicates that this failure here is a cause for pizza containing gluten. So if I choose the wrong flour type, the pizza could contain gluten. So I drag and drop this one in here, and you see now this new failure is added to this, or as a cause to pizza contains gluten. I can even use these function links by such a filter function. So I can only see functions which are linked to the selected function. And I can discuss with the team now which of those failures are potentially causes for pizza containing gluten. And well, DAF consistency incorrect in the DAF making process, that does not fit, so I have to add a new failure. I will do. And this is DAF contains gluten. So sounds stupid, but it is the truth. If the DAF contains gluten, my pizza contains gluten, and this could lead to an allergic shock by my customer. Pizza not well formed is also not a cause. Where am I? Here. So I have to add a new failure, and that is pizza contaminated with gluten. So during the forming process, that could be the problem here. And we see the same risk here in the pizza baking process. So I add a new failure with the same wording here. as these are different process steps. Come on. Now it reacts. So I have my causes now linked directly to my design. Of course, these causes here are failures in my process FMEA and will be handled separately later. When we have a look at our design FMEA now, we'll step in design FMEA, so go to risk analysis, DFMEA, and of course I have to update, and then I can see that, let me scroll down, I have a failure in here, a new failure, new function, new higher level function, everything is there, and there's the new failure, pizza contains gluten, with the effect of an allergic shock and those 4 causes. 3 of these causes are coming from the process, and yeah, I typically use it like this to write down PFMEA because I don't want to make the further analysis here. But to make it easier to watch, I can also filter out by selecting the system element type filter to say, well, I only want to see causes from design elements. When I say save, this pizza contains gluten only has one cause. This is wrong flour type. So the first question is, what's my severity of the allergic shock? And this can be easily entered on this higher level. So I just go there by clicking on this origin link, and I can add a severity rating easily here. And I can go downwards. You see here, allergic shock is now the failure on this higher level. Pizza contains gluten is the cause. And when I click on the origin link of pizza contains gluten, I move downwards, and after updating that form, you will see that there is a severity 10 offered from above. And the tool recognizes, well, there is something going wrong, so I have to apply the inherited evaluation here. And now the severity 10 is forward. Of course, once this high-level severity is assigned to a failure, it's automatically assigned to the failures by linking them. So you do not have to do this every time. This is just because I added this failure afterwards without a severity. All right. So let me think about the actions here. So let's go to step 5 and step 6 in my FMEA. Then I have to think about this wrong flour type, and I know that this failure is used another time here at the very beginning of my pizza, so pizza base not crispy enough. And here we don't see any problem, but we use this 00 quality, which contains a lot of gluten. Gluten is a quality, a sign of quality for such pizza flour. So this is a challenge. So what I'd like to do now is filter for this particular cause to have it all in one view. And now I can discuss with my team what to do. So I'd like to start downwards here. The wrong flour type. Well, how can we make sure that our pizza does not contain gluten because of the wrong flour type? 00 quality is definitely wrong. We have to use gluten-free quality. And of course, I cannot use the 00 quality up here, so I have to delete that one, right? So let me think about, this gluten-free quality, well, this should be the same up here, and it is maybe a preventive control, or should be a preventive control also here for pizza base not crispy enough. But maybe I have a different risk here. So I copy that element, sorry, make it with the mouse, with the right click, not with Control-C, and I paste it in here. And I can copy that action as a link. So it's the identical action. So if I decide to use quality 4711, so that's the name of that one. You can see it changes everywhere. That's a nice feature. So let's think about the rating. If we use this 4711 flour, we are sure that the occurrence of wrong flour type leading to pizza contains gluten is a 1. You see the 1 is also automatically entered up here, but in this case, we can't be that sure. So we have to modify that rating because, well, it's a new flour type. We can't be sure that the crispiness is still there. Okay. We do not have a detection control planned here. So it's the same in both cases. So I have to choose the correct rating. And yeah, in this case up here, I may do some test series. I have to do something. So I can add here to identify correct flour. So I add a test series here. This is a preventive action to make sure that this flour type works for us. So responsible is me, of course, and the target completion date. Well, let's choose any date and to say, let's say that, well, we hopefully come to a medium occurrence rating, and maybe we have to do some trial production with tasting. So I prefer tasting than testing. So that's a detection. And who's responsible here? I don't know if I have. Let me use my name as another responsible here, and let's say, well, this should be done by end of April, for example, and could lead to a detection of, let's say, a 3, and then we have it hopefully on a green level. That asterisk icon here indicates it's a forecast, and we have to close those actions and re-evaluate them first until this gets a valid evaluation. All right, so we recognize now that the flour type is very important to ensure that gluten-free pizza. So we want to think, or we have to think about special characteristics now. So that's our next step and the last step in the design phase. That is our module, special characteristics. And there we have the design SC form, design special characteristics form, which allows us to document the decisions on special characteristics. So just to show you here, that line or the concept of that tool is on the left half of this table, we have the current state. It starts with the function. So you see here the function provides best crispiness. You see the maximum severity within these functions. So we have a tooltip here indicating what it means. We have the filter code, and we can filter for these functions. So I made a filter. I added a numerical filter here, to have added one, greater or equal than 8. That means I want to filter for functions which are linked to severities 8, 9, and 10, which are typically functional, legal, and safety related. All other functions, that's my decision as a pizza producing company, are not relevant regarding special characteristics. So I have here the function crispiness, the function taste, and the new function is still missing. Maybe it's not catched by the filter. Let me see. I removed the filter, and we have this filter did not properly work since so. Ensure that pizza is free from gluten, and you can see the severity 10 here. So let me filter again. Should work. Greater or equal than 8. and I say save. So we have now that new function down here. And then we have the characteristics. We can select the characteristics which are linked to that function. So there are several characteristics in my FMEA already defined in the design FMEA, like the flower type you can see here. And let's have a look at the flower type. Regarding the crispiness, the flower type was seen as a robust parameter. This is the translation of that, because in the right half of the table we have the option now to filter out characteristics, to say, well, I have a robust concept or a robust design, and the flower type was filtered out by ticking this checkbox and adding a comment, and then we said apply, and the comment here is stored in a history. So we said the flower is not relevant regarding crispiness. Right? The flower type is not relevant here. The crispiness rating, for example, which is a characteristic for the complete pizza, that was a requirement from the customer to have this marked as a special characteristic. So it is this checkbox here was used, and it's indicated as an externally classified characteristic. So there is no discussion about filtering possible. And let me see the water amount, for example, down here. There in the design FMEA, the team found out that it is a sensitive parameter and needs attention. So an SCF was assigned, and you can see the comment here. And this other comment here is coming from the process FMEA, which is already done. So there is also a process SC form sheet. So in this sheet, you can have a you have the chance to make a documentation on special characteristics, to document why a characteristic was classified as a special characteristic or why not, which is also very important. And this work is done for these two functions. So I want to step to my new function here, and just by double clicking here, the tool offers me all related characteristics. And of course, the flower type is the only one. So I select this one, and you can see the flower type is automatically added here. Just see that I did not change the characteristic, the original value. It's still 00. So I can edit this characteristic here. So let me jump there into my characteristic editor. Flower type is, what did we say, 4711. And I close that window, go back here, update that window here, and you can see it's 4711. You see also that the flower type brings its history. So this characteristic only exists once, and you can see the comment was flower not relevant regarding crispiness. So let's think about that parameter, that characteristic now regarding that new function combined with the severity 10, and the team says, well, of course we have to make sure that we use the right flower type. So this is a very, I just write down a sensitive parameter. No, that's not more than sensitive. That's let me say a safety relevant parameter. So I assign here an SCS. When I click on apply, that button turns green. This new decision is documented, and you can see here this last entry which I just did. For all characteristics handled here, we have a combination or a collection of all decisions in what we call the decision documentation sheet. So when I click on that link, history, this decision documentation opens, and you can see here, that's the flower type is already marked. You can see here the characteristic with its value, so 4711. It is S classified, and you can see the historical entries, who did what, when, and where. So you see, for the world's best crispiness, we applied the design filter. In the process FMEA, we said that we confirmed that decision that no classification is done, but then we changed the characteristic to an S characteristic because it's safety relevant regarding that gluten-free. All right, that was it for the design FMEA. Let me go to the process FMEA and let's have a quick look into our flow chart just to show you that this is existing. So the process FMEA is down here and is done on that element here. And you see here the duff making, duff rising, form pizza base. These are the process steps you already saw. And when I go here to that icon, you can see in the pop-up that the flower type is a characteristic, S characteristic, already recognized here in my process. So yeah, well, I think that's quite nice. And of course, building a process FMEA with the flow and with the corresponding to the process flow chart here, you can assign product and process characteristics to process steps. And you can see this was already done. So the flower type was already assigned to my process step duff making. It's already there. And as we changed it to an S classified characteristic, it's now a special characteristic. That's new to my tool. And when I go to my process FMEA now, and I choose the PFMEA process flowchart based form sheet, I can see now, oh, let's ignore that one. I can see now the process step, the duff making. I can see two columns for design and process characteristics. So these are the characteristics assigned in PFC. So they are always visible, and the flower type 4711 classified as an S characteristic is also displayed here, again with an origin link where I can navigate there. And if I have the right access to that element, I can edit it. And well, let's see. I think I have to update once because something, my mistake. I think, well, here it is. Yeah, I was just searching for this new failure here. Pizza contains gluten. And here we have the same situation than before. Severity 10 was used a level above, but it was linked before it was assigned to this failure, so I can apply that in that evaluation again here. And now, well, I'm in the process FMEA. I have a new failure identified here, a new potential failure. Duff contains gluten for my gluten-free pizza, which did not exist yet. I have no causes yet. So again, I'm stepping into my net builder. This is how I usually do it. And discuss with my team what can be potential causes for my pizza containing gluten. And you can already see functions which are linked here to that main function, the duff making. Of course, they are all linked because of the duff consistency incorrect. But when we go through that list here, we can find, well, a process step where the pizzaiolo, the guy who's creating the pizza, is weighing all the ingredients, of course, and if he uses the wrong flour here in this moment, this could be a potential cause, so I have to add this one. So containing gluten. So I can add this failure here and directly link it. So this was not existing in the original pizza, right? And well, I think this guy has also a new function to fulfill. That is cleaning of the equipment. Let me keep it short. And I can directly add a failure here. No, come on. Let me keep it short. So the cleaning is insufficient, and that is another cause, that the potential cause that my duff contains gluten. Going back to my pizza, to my design FMEA, and after updating, I can see now this new failure with the new causes and can go on with the discussion about preventive controls, detection controls, and so on. Evaluate the risk, and of course, I need to be on a good level to be sure that that no one gets injured, because the severity here is still a 10. I want to skip that step because just recognize that the time is nearly used. So I want to show you now, as the second last step, the special characteristics from the process perspective. And you can see here in my duff making process, I have the wrong filter active. That's why this one is not working. So here's my duff making process, and well, the form sheet for special characteristics looks very similar to the one the process one looks very similar to the design one. We have the process step, we have the product characteristics, the process characteristics, which were assigned in before when we created our process flowchart, and well, of course, now we have the product process characteristics here and can also decide, for example, the duff temperature after netting should become an SEF. This was also already done in the original pizza example. And you can see now the flour type here. And you can see it is an S characteristic. And the original entry here was that no classification was confirmed by industrial engineering. Of course, that's bullshit now. So we have to confirm or to reject that S classification. So I can should edit this. So the S classification is now confirmed and accepted by industrial engineering. So we assign again an S characteristic. So once I change this button turns orange. So I have to apply again. And everything is green and fine now. So this is an optional step. This S characteristic, nothing has changed for the characteristic itself, but I have a documented decision from the process side to say, well, we accept this classification. And now I want to have a look into my control plan again. So let me step there. And let's see what happens. And I also update this one here. This is the control plan I showed you in the beginning. And this flour type is missing because I focused only on special characteristics. And now I have to add this one, or I can add this one. And this is done in the process configurator, which is a special tool for, let me say, the definition of the control plan. And I can select now or filter now for classified characteristics. So I have this F and S characteristics here, and I can filter for them. And I can see now that the characteristics are used once in one process step. And when I go downwards here to my product specification, I come to my duff, and I need to update maybe. Filter again, sorry for that. And you can see the flour type is now listed, and it is already assigned to the process flowchart, but not to the control plan. When I do this, and I update here, I can see flower type is part of my control plan and is can be analyzed and handled as the others. So everything is prepared now, and well, our project is close to be finished. So let me go back to my presentation. So I showed you what this webinar is about, and let's have a quick review. What was this webinar about? It was about this circle, and you saw me entering a new requirement into my pizza project, doing function analysis, going over to the failure analysis, doing the risk evaluation and optimization in my design FMEA, and discussing about special characteristics. So that is the development side, product development, and now we hand it over to the process development with the process flow, function analysis in the process FMEA, also the function and failure analysis, sorry, the risk evaluation, the special characteristic, and we ended up in the control plan. So this complete circle is closed in, as I think, a very good way. And yeah, I hope you were able to see how all fits together and works hand in hand.